All right, welcome to section 6.4, part 1. We're going to have a quiz after section 6.4, so once we get all the parts done of this, we're about the halfway point, so then we'll have a quiz. But what we're going to learn today is how to transform graphs of exponential functions. Okay, so let's not forget exponential functions are equations that have the equate function y equals b raised to the x. Okay, so anything with the x and the exponent, that's an exponential function. And what does it mean to transform? Okay, transform just means change the graph. You can move it, you can reflect it, you can make it bigger, you can make it smaller. Anything that will change our original graph, that's a transformation. Okay, so the next 5 slides are going to talk about the different transformations that we're going to talk about. The first transformation is a horizontal translation. Okay, that is if the graph moves right or left. Okay, so anytime the graph moves right or left, it's called a horizontal translation. All right, so we have some function notation here. That just means what will our function look like if we're translating it. Okay, so the function will look like the x value will have some number h attached to it. Okay, so it can either be a positive h or a negative h. That's why I put a plus or minus. All right, so let's look at 2 examples, one of each. So our first example, let's say we have 4 raised to the x plus 2. And let's say our second example was 4 raised to the x minus 3. Okay, so the plus 2 and the minus 3 are going to move the graph right or left, and we just have to remember which one is which. Okay, so a positive 2 you would think would move the graph to the right, but really it's going to move the graph to the left 2. Okay, so that whole graph is going to shift left 2. The minus 3, so the plus 2 moves left 2. The minus 3 you would think would move to the left, but it really moves to the right 3 units. So it just goes by whatever the number is. You just have to remember that positive is left, negative is right. So if we want to write this down, okay, so positive h moves your graph to the left, and a negative h moves the graph to the right. Okay, so we'll look more at the graphs of these, but this is kind of the general rules for the translations. Okay, that's number 1. Number 2 is vertical, a vertical translation. Okay, so for this, the function notation, so this is going to go up or down. Okay, and the function notation for this one is you take your whole function and you add some k to it. Okay, so you're going to take your entire function and then you're going to add or subtract a k. So for instance, let's write a couple of examples down here. So let's say g of x equals 4 raised to the x plus 5, or another possibility would be g of x equals 4 to the x minus 6. Okay, so each of these do something to our graph. The plus 5, so notice we have our exponential function and then the number is after it. It's not in the exponent anymore. It's after the equation. So this one is going to go up 5, so plus 5 goes up 5, and negative 6 goes down 6. Okay, so if we want to write down a little cheat sheet here, a positive k is going to go up, and a negative k goes down. So k's do the direction that you would think that it would go in. Okay, so that's a right, left, up, and down change. So we've done 2. Okay, now we have reflection. Okay, we can reflect 2 different ways. A reflectant is just a flip. Okay, so if you see a reflection in a lake or a pond, you're upside down. That's what reflection does. All right, so we have 2 types of reflections. We can reflect over the x-axis, or we can reflect over the y-axis. Okay, and each of these have its own function notation. All right, so if you're going to reflect over the x-axis, you're just going to make the x the opposite. Okay, you're going to change the sign of the x's. If you're going to do a y-axis, you're going to take your function and you're going to multiply the whole thing by a negative. Okay, so that will reflect us over the y-axis, and that won't make any sense until we see some examples. But let's look here at what an example of a function will look like for each of these. Okay, so once again, we're on x-axis. If we're going to reflect over the x, you just change the x to a negative. So for example, g to the x equals 4 to the negative x. So we're making just our x part negative. If we're doing a y-axis reflection, you would make the entire thing a negative. So I'm going to do 4 to the x, and I'm going to put the negative on the outside. So that will reflect our graph over the y-axis. Okay, and you can graph these on your calculator and see what they do. They do reflect, so I promise. All right, so there's number 3 of 5. X-axis, just change your x to a negative. Y-axis, you change the whole function to a negative. All right. All right, so the fourth one, we have a horizontal stretch or shrink. Okay, so basically what this does is it moves your graph closer to and further from the y-axis. Okay, so a horizontal stretch or shrink, it moves your graph closer to, and I should actually, instead of and, I should actually write or, because it's one or the other. Okay, so how do we do this? Okay, the function notation for this one is we are going to take our x value and we're going to multiply it by some number. Okay, so we're going to take some a value and multiply it by our x. Okay, so we have two examples here of a stretch and a shrink. So g of x equals 4 to the 2x, and the second one we're going to say g of x equals 4 to the 1/2 x. Okay, so this will one's going to be a shrink, one's going to be a stretch. So which one would be which? Okay, so if we're multiplying by a whole number, this is actually a shrink by a factor of 1/2. Okay, and if we're going to multiply by a fraction by our x, it is actually a stretch by 2. Okay, so how can we remember if it's a fraction or a whole number? If we're talking about a horizontal stretch or shrink, you always take the reciprocal. So if it says you're doing a factor of 1/2, you take the reciprocal and that's what you multiply by. And if it says you're doing a stretch by 2, you take the reciprocal of 2 and that's what you multiply by. Okay, so once again, this isn't easy stuff. We're going to need to do some practice. And last but not least, we have a vertical stretch or shrink. So this moves graph closer to or further from the x-axis. Okay, so it's going to stretch it vertically. Okay, it's going to stretch it vertically up and down. All right, and our function notation here is we're going to multiply our whole function by a number. So we're going to take a and we're going to multiply it by the whole function, not just the x value. So our two examples for this one are g of x equals 3 times 4 to the x, or g of x equals 1/4 4 to the x. Okay, so we're multiplying our whole function by a number. And what do each of these do? Okay, so the first one is a stretch by 3, and the other one is a shrink by 1/4. So for verticals, okay, so we're only talking about verticals, you just use the number. Okay, if it says stretch it by 3, you just multiply by 3. If it says shrink by 1/4, you just multiply it by 1/4, which is completely opposite of horizontal. If it says shrink by 1/2, you use the reciprocal, so 2. And if it says stretch by 2, you use the reciprocal, which is 1/2. So that's for horizontal. Okay, so those are our 5 transformations. We have left or right, up or down. We have 2 reflections, x-axis, y-axis. We have a stretch and a shrink of horizontally, left and right, and we have a vertical stretch up and down. Okay, so let's look at a few examples. All right, so we have to state the transformation that g of x produces. So our first equation is 1/2 x, and this one is 1/2x minus 4. Okay, so what does this minus 4 do? And I'm going to go back to my transformations, and I notice that if we take our function, we add or subtract a number, k, it is a vertical translation. So this first example, this minus 4 here, is going to make our whole graph go down 4. Okay, and we can check our answers very easily. If you go to your calculator if you see I have 1/2 raised to the x, which is the first one, and if I graph it, there it is, an exponential decay. And then if I turn on the next one, where I've just taken 1/2 raised to the x and I've subtracted the 4, so let me turn that one on, you will see what it does. And you notice that it drops the whole thing down 4. 1, 2, 3, 4. Okay, so you can check your work. You can see what it does. Okay, so there's example 1. It's going to go down 4. All right, so let's see what this one does. We have e to the x, and now we have this plus 3, and we have a plus 2. Well, we should recognize what this one does. The plus 2 is going to go up 2. Okay, so anytime it's after the equation, it's up or down by whatever the number is. Now, this plus 3 is a little different. Okay, this plus 3 is attached to the x. When it's attached to the x, it's either left or right. If it's a positive 3, and you go back to your cheat sheet, a positive 3, so like positive 2, it's going to go left by 2. So this one should go positive 3, it should go left 3. Okay, so the positive 3 is going to move it left 3, the positive 2 is going to move it up 2. Okay? All right, so let's see here. We have 3 raised to the x, and then 3 raised to the 3x minus 5. So there's two things here. So the minus 5 we just did, that's left or right. So this one's going to go right 5, minus goes right. And then now notice we've also have this times 3 to just the x part. It's multiplying the x by 3. Okay, so let's go back to our stretches or our shrinks. So notice that the horizontal stretch or shrink is the one that multiplies by a number. So if it's multiplying by a whole number, it's actually a shrink by the reciprocal of it. So the reciprocal of 2 is 1/2. So let's go by this one. This one was multiplying by 3. So it's going to be a horizontal shrink by the reciprocal of 3, which is 1/3. Okay, so those are the two different types of examples by there. Okay, so last one here. Got a couple different things going on here. Notice we have e to the negative x, e to the negative x. So this one we've multiplied by a negative 1/8. Okay, so let's figure out what this negative does. If I multiply my whole function by a negative, what is that going to do? So multiply the whole function by a negative. So if I take the whole function and multiply by a negative, that's a reflection over the y-axis. Okay, so that's our first one. So that negative is a reflection over the y-axis. Okay. Now, what does multiplying the whole function by 1/8 do? Okay, so let's find that cheat sheet. Okay, so when we multiply our whole function by an a value, this one was, in our example, is 1/8. This one's 1/4. It's a shrink by 1/4. Okay, so it's a vertical shrink by 1/4. So what is this one going to be? This one should be a vertical shrink by 1/8. Okay, so there is your cheat sheet. We've done a few examples. We'll work on this tomorrow, and I will see you then.